I'm Joel, co-founder of Gearbox Labs and architect of Ceramic. Today I'm going to be talking about, in general, how we can notarize data in science and sort of why we actually want to do that. So data is, and has always been, the cornerstone of science, but it's becoming even more so now as we are computerizing pretty much everything. Science is becoming a heavyweight in data. And this also means that in order to reproduce science, we need access to the data. Because if we don't have access to the data, it's sort of like, if you're familiar with software development, trying to write software without having any tests. So the data used to produce our scientific results are actually very important that we have some sort of public record. Otherwise, the science is not that useful. But there are some challenges currently, right? A lot of the data in science right now is proprietary or simply like not available for the public to use. And when it is available to the public, it can often be like difficult to validate the data and see that this is actually the data that was used in the study. Data integrity here is important to know that something hasn't been modified after the fact. And also with this fact of like more data in science, we also have more data from more sources. And with that, we have a problem of trust. Like, can we trust all these different sources that the data comes from? So given all that, what if we could know for sure when the first time a piece of data was published, and who published that data, and in addition to that, also that the data has not been tampered with, so no one has gone there and like modified the data since after it was published. And what if we had a scientific feedback loop where we could easily crowdsource information from a wide range of people without this problem of trust and like basically making it easier for us to deduce who we can trust in this like large group of crowdsourced data? And what if we can actually also reward the participants in this process? What if we could leverage more real-time data, like weather data and IoT sensors and all kinds of signals from nature that we can just like pick up? And what if all this data had standardized schemas? I think if you think about this a little bit, it's easy to see that that could actually like change how we do science to make it like much more efficient and potentially much better than it currently is. And so why is notarizing data sets important in this? And how can actually crypto Web3 technology help with this? Also, we can fingerprint data. We can see that data has not been tampered with. And we can to do this, we can use cryptographic hashes. We want strong identity. We want to know who published a piece of data. Even if it's just like a small piece of data in this crowdsourced system, we want to be able to see who did it, at least with some pseudonymous identifier. You can use public key cryptography for that. And we want to be able to timestamp data and have that be secure. And that's one of the things that blockchains are really good at. All right, so can't we just use existing decentralized solutions? You put it on IPFS.
No.
No.
I'll tell you why.
Yeah.
Keep going.
Okay. Yeah, we'll be happy to hear. So on IPFS, you publish data. The data is kind of like static. You can create a file, you have a hash, but if you want to update the data, you can't. And there's also no like signatures involved in IPFS.
Well, you put it on Filecoin.
In Filecoin also, like it's very difficult to use. For example, it's
I can help with that.
Sure. What if you put it directly on chain? Well, it turns out that's pretty expensive. Also, like there are a bunch of things to consider around privacy. So in order to address some of these things, I've been working on a project called Ceramic. You can think of it as a decentralized data ledger, where essentially data is created off-chain in a hash-linked data structure, which essentially means that individual users sign each piece of data that they add to the data set, and we have this like immutable log of data, where we can keep track of the growing set of data as it evolves. And this data is periodically timestamped onto the Ethereum blockchain. In addition to this, we built a system of peer-to-peer replication that allows anyone to spin up a node and replicate any subset, any data set in this network. And all the data is authored into the network is attributable to a user account, basically their cryptocurrency wallet. And in order to like make this experience good, like if you ever used a normal Web2 application, you notice that you sign in once, and then you use the application. If you ever use the Web3 application, you notice that every interaction you make, you have to like sign a transaction, and it's kind of like can get annoying. And it's fine for like financial type of things, but if you're dealing with it's like writing comments or doing a peer review, you might not want to like sign every interaction you make. In order to combat this problem, we can use something called object capabilities. Object capabilities allows us to delegate a key that lives securely in the user's browser from the user's wallet and basically delegate some permission to that key. So the wallet delegates permission to a session key that can act on your behalf on a particular resource. So that's how we can like make the experience of this be you sign in once and then you kind of just use the application, but still all of the interactions are cryptographically attributable. So in order to make ceramic, that is, yeah, go back.
But yeah, just because, so if you have access to the raw data, like at the file system level, you're assuming it's encrypted, right? Meaning like, I need that key to do anything with the data? Or is this just at the application session layer?
Yeah, so this is just like this is not assuming encryption here.
Okay.
If you assume encryption, you need to have some additional delegation from the wallet to somehow delegate some sort of encryption key. But this is just like for pure authorship, right? So you delegate the permission for the session key to author something on behalf of your wallet's identity.
Your version of OAuth, I guess, right?
Yeah, I think it's like slightly different because you're using these like object capabilities. So basically, this session key can act on behalf of your wallet's account, given that it displays this signed object that comes from the wallet. So it needs to include that as a proof.
And it could delegate permissions to other wallets to be able to access information within.
In theory, yeah.
In theory, okay. Not built.
Not currently, yeah. So ComposeDB is the first decentralized database that's built on Ceramic. Essentially provides a GraphQL interface on top of this like event streaming layer that Ceramic is on the base layer. And allows you to create data models using the GraphQL schema definition language and also read and write data using GraphQL. So you don't have to learn a bunch about the kind of lower level cryptography stuff. And all this ComposeDB is just indexing a bunch of these cryptographic event streams and putting them into a Postgres database. And these data models, as I mentioned, they're created using the GraphQL schema definition language. And the nice thing about them is that you can find these models like this. So here we have a data set and we have a paper, and we can see that the paper essentially like refers to a data set. And so let's say someone builds an application that has the data set and the paper. Someone comes along and like, yeah, but we need reviews for scientific papers. So they build a new application that just imports the two data models that were created by the previous application, creates a new data model called a review, and then you just like start running their application. And now you actually have two different applications that compose on the same data, but one of the applications has this extended functionality of reviews. So the applications can remain fully interoperable, while you can permissionlessly add new features. And there's an emerging DeSci ecosystem on top of Ceramic and ComposeDB. There's some smaller projects experimenting with building different sorts of like vector databases. Some people experimenting with community peer reviews, different ways of versioning datasets, and knowledge graphs. So two projects that I like to call out is Coordination Network. They're building this tool for essentially creating research plans in like a graph-based model. while also allowing you to edit the graph using a large language model. DeSci Labs is building a pretty cool way of publishing data and also doing like a community-style peer review. And since all of these applications live on Ceramic, you can actually go onto one of the data explorers, either Cerscan or S3, and explore the different data models and explore the data within those models. All right, so let's build the scientific data commons. All right, thank you.
I have some architecture questions. I apologize, I'm from Falcon Foundation, and I have worked with some people from DeSci Labs. I don't think they're here. How are you generating the data set DIDs? Can you go back to that graph where you actually had IPFS and then you had your own P2P setup?
This thing or?
To that one, sorry.
This one?
Yes, so you have an Ethereum dependency, you have IPFS that does just for logging, so that's JSON data or contextual data.
Yeah, so we have,
unencrypted.
yeah, it's unencrypted. So we have this event logs.
You run your own IPFS node?
Yeah, so let me take one piece at a time. So we have event log that's IPLD compatible.
Got it.
So right now we're using the Kubo IPFS implementation. And this event log is basically one per user. And so you kind of like can arbitrarily shard the network based on users.
How does the user run that? So the Kubo node, where is it embedded? It's when you say user, like the user has like a DMG or an executable that they launch, and it.
So the end user basically is have a GraphQL kind of, as an application developer, you use a GraphQL interface that talks to a Ceramic node. And so the Ceramic node basically exposes the GraphQL interface and also underneath the hood runs the IPFS node.
Okay. So it needs some amount of power and bandwidth, right? I mean, especially because it's advertising itself to public IPFS.
Yeah, so right now we're using the Kubo Go implementation of IPFS.
Yeah.
We're actually in the process of migrating over to a Rust implementation that's based on something called Beetle, which is like a Rust implementation of IPFS. And the reason we're doing that is because we want to go one step lower into libp2p and we're building a new peer-to-peer replication layer for these data sets because IPFS and Bitswap is good at replicating individual pieces of data. And we've been using Gossip Sub for gossiping about updates, but it's not really scalable for the type of use case we have. So we actually built a custom libp2p protocol that allows us to better synchronize expanding data sets that grow over time.
How long does it take for me to turn up a node? Whatever, from a runbook standpoint, I'm just curious.
It depends. So spinning up a node is very quick. But if you want to synchronize data in the network, that will take a variable amount of time depending on how big the data set is you want to synchronize.
And from a customer standpoint, I have a question about one, like where are most of them deploying? Is it on-prem or are they using cloud account that they use for their university? And then what are they're not getting crushed on egress fees if they turn it up in the cloud environment?
So
because it'd be replicating the DHT. I see this all the time where people like advertise these public nodes and then they get their bill 3 months later and I had already forewarned them. That's why I'm always like cautious about people implementing IPFS and turning it up as a.
No, I think it's a good point, and like it's not something we have optimized currently. There are some projects in the DeSci space which I mentioned, but most projects building on Ceramic is outside of DeSci in the broader Web3 space. But on your point on like the DHT part, we are actually considering turning off the DHT for like every individual IPFS record because it's just like eats so much resources.
Yeah, I think you should for sure.
And instead just like advertising specific, basically in this replication protocol I talked about, you can specify ranges of events and essentially just advertise a smaller set of data. So you don't, and the fact that you find someone that has that data, that range of data, means that they probably can give that data to you.
And I guess I'll ask a question about the libp2p part. So that portion is the large data set in that it could be some physics data or HPLC data coming from a machine. Like what is being replicated at the libpdp side?
Yeah, so currently all data in ceramic is just this hash linked log. And right now there's no like big scientific data sets on there. There's some of these like that I mentioned, like coordination network or DeSci Labs. I think their data sets are still pretty small in comparison to like what you would have in a large scientific data set. But what is being replicated over libpdp is like all the data in these event streams. In theory, you could put a hash of some data into an event stream and then point to that somehow. But yeah, that's how it works right now.
But the goal of that is for the large data set replication, correct?
The goal of which?
The libp2p portion.
The libpdp portion is
Like
more,
how do you replicate a petabyte of data between one node to the other?
yeah, I mean, you could do that over that, but the reason we built this libpdp subprotocol is that if you have a growing data set, you can't really use IPFS to let other people know.
Too slow.
You don't have a way to get the other people the updated hashes, right? And the only thing you can do is PubSub, which actually has been disabled in IPFS, but it's also not scalable. And so we needed to build a peer-to-peer protocol that allows us to have a expanding, growing data set and be able to keep nodes in sync. And so that's what we're doing on libpdp.
That's great, yeah. That's really smart, actually. So I have a question, maybe there's somebody from DeSci Labs in here. Is this related to DeSci.nodes?
So
is there an integration here that I'm missing? And I have
yeah, so DeSci Labs, they are implementing a new version of their protocol on top of Ceramic and ComposeDB.
Okay, good. And it's using all of this.
Yeah.
We can talk a little bit more about the IPFS stuff so the problems don't stack up.
Definitely, yeah. Anyone else have any other questions? All right, thank you.